everyone, in this video let us study about expectations and variance with respect to single random variable. Let us try to understand the meaning of expectations. Expectation is also known as expected value, or it is mean or average. Let us try to define this expectation. Let x be the discrete random variable with range Rx is equal to x1, x2, x3, so on. This can be finite or countably infinite. The expected value of Ex is denoted by E of x is defined as x bar is equal to E of x is equal to mu x, that is equal to integral of x fx of x dx with respect to within the limit minus infinity to infinity. E of x or E of y is the expectation operator. If x is a random variable, then it is E of x. Y is a random variable, then it is E of y. X bar is the mean of random variable x, and fx of x is known as PDF. It includes the information on all possible observations of x. There are many expectations defined with respect to single random variable. Let us restrict our study to the main three expectations which are shown in this slide. First moment about the origin, which we have already defined. It is called as expectation x bar is equal to mu x, that is equal to integral of x fx dx with respect to dx within the interval minus infinity to plus infinity. Second moment about the origin, it is also known as mean of square of x. It is x square bar is equal to E of x square is equal to integral of x square fx of x dx between the interval minus infinity to infinity. Third one, second moment about the mean, which is popularly known as variance. VAR of x is equal to sigma x square, that is equal to expectation of x minus mu x whole square, that is equal to integral of x minus mu x whole square fx of x dx between the interval minus infinity to infinity, where we call sigma x as standard deviation, and it is always a non-negative quantity. So sigma x is equal to plus root of variance of x. Some examples, we try to understand how to calculate the expectations given the PDF. Let us take the first example. Fy of y is defined as 1 divided by y2 minus y1 within the limit y2 and y1. We have to calculate all the three expectations. First moment about the origin. So y bar, that is equal to E of y is equal to mu y is equal to integral of y fy of y dx between the interval minus infinity to infinity. So let us try to define this. Y divided by fy of y is given as 1 divided by y2 minus y1. We are going to integrate with respect to y. This gives us y square by 2 y2 minus y1. We have integrated between the limits y1 to y2. Let us substitute here. It is y2 minus y1 whole square divided by 2 y2 minus y1. So you will be getting it as y2 minus y1 by 2. Second one, second moment about the origin, mean of square of x. So it means y square, that is equal to E of y square. The mean of y square, that is equal to E of y square, that is the integral of y square fy of y dy between the limits minus infinity to infinity. So therefore, it is integral of y square dy y2 minus y1 between the intervals y1 to y2. When we integrate this, we get y cube by 3 y2 minus y1 between the limits y1 to y2. When you simplify this, we get y2 minus y1 square by 3. We try to solve the third part of the example, that is second moment about the mean. We need to calculate variance. Variance of y is equal to standard deviation whole square is equal to expectation of y minus mean the whole square. That is the integral of y minus mu y whole square fy of y dy. That is equal to integration of y minus mu y whole square divided by y2 minus y1 dy between the integrals y1 to y2. Now, let us try to expand this term, that gives you y square minus 2 mu y into y, and then this is plus mu y whole square. Let us substitute this here. We get this as 1 over y2 minus y1 is a constant term which is taken out. Then each of them separately they are integrated here. So when we integrate this, we get the first term as y cube by 3. Second integration gives us y square by 2. Third integration will give us 1. So we need to substitute the boundary condition y1 to y2. When we substitute this in this, uh, we get y2 minus y1 square by 3 minus 2 mu y y2 minus y1 by 2 plus mu y whole square. So on further simplification, we can substitute the value of mu. So y2 minus y1 whole square by 3, and this gives you 2 times y2 minus y1 by 2 multiplied by y2 minus y1 by 2 plus y2 minus y1 whole square by 4. Further simplification gives us this is equal to y2 minus y1 whole square by 3, and this gives you y2 minus y1 whole square by 2, and this gives you y2 minus y1 whole square by 4. So common denominator we can take it as 12. So when you take this as 12, this has to be multiplied by 4, this has to be multiplied by 6, and this has to be multiplied by 3. 4 plus 3 is 7. 7 minus 6, that gives you 1 in the numerator. So you have y2 minus y1 square by 12. Example 2. Find all the three expectations for the random variable s uniformly distributed between 0 and 1. PDF is given as fx of s is equal to 1 for all values of s varying between 0 to 1. It is 0 otherwise. So we calculate the first one, x bar, that is expectation of x, that is mu x, is equal to integral of x fx of x dx, that is integral of x into dx, that is equal to x square by 2. When we apply the boundary conditions, we get this as half. Second one, x the square mean, that is equal to expectation of x square, which is the integral of x square fx of x dx, that is integral of x square dx, that gives you x cubed by 3, that is equal to 1 over 3. Third one is the variance of x, that is standard deviation whole square, is equal to expectations of x minus mu x whole square, that is equal to integral of x minus mu x whole square fx of x dx, that gives you integration of x minus half whole square dx. When you simplify this, you get this as x minus 1 by 2 whole cube divided by 3. Let us apply the boundary condition 0 to 1. We get the answer as 1 by 12. Here we have applied the boundary condition. The boundary condition is 0 to 1. So when we apply this, we get this as 1 by 12. Solve some problems. First problem, the PDF for the random variable y is given to us. Fy of y is equal to 1.51 minus y square for values of y between 0 to 1 and 0 otherwise. What are the mean of the square variance of the random variable y? First, let us find the expectation of y, that is also known as y bar, that is mean, mu y, is equal to integral of y fy of y dy. That is, here the limit is given as 0 to 1 and y into fy of y dy. When we simplify this, we get the answer as 0.375. Second one, we'll find the expectation of y square, that is y square mean, is given by integral of y square fy of y dy. Now here it is y square into fy of y dy being integrated between the interval 0 to 1. We get the answer as 0.2. Finally, we need to calculate variance of y. It is given as sigma y square, that is expectation of y minus mean whole square, that when we put the value, we get the answer as 0.05935. We solve the second problem. A PDF is described by 1 by 8 z minus 6 for all values of z between 6 and 10 and is 0 otherwise. What are the mean of the square variance of the random variable z? First, let us find expectation of z, E of z. It is the integral of z 1 by 8 z minus 6 dz between the interval 6 to 10. When we simplify this, we get this as 8.667. Second one, we need to find out the mean of square. So we get this as we have to integrate z square 1 by 8 z minus 6 dz in the interval 6 to 10. We get the answer as 76. Third one, variance of z, it is sigma z whole square. When we put the value z minus mu z, so mu z we have already got it as 8.67, z minus 8.67 whole square multiplied by fz of z, and entire thing needs to be integrated with respect to z over the interval 6 to 10. When we simplify this, we get the answer as 1.046. Thank you. In the next video, we study the properties of variance as well as characteristic functions.